Start recording. Okay, I am recording. We can confirm I'm recording. So let's get cracking. Last time, we started off with the idea of links. Or last time we ended with starting with the idea of links and link structures. But again, big warning. At this point, we are not talking about something like a stack or a queue or a list, bag, tree, graph. At this point, we're talking simply about this idea of linking structures, linking things together. What I'm talking about is going to be more analogous to like an array than any of the other, like the stack, the queue, or anything. And okay, when we're using an array, they have fixed size, and if we like have a long array and there's something in the middle that we want to remove, we're gonna have this hole in the array, this gap, and we're gonna have to like move things around, right? But now we can talk about something called like a linked structure. And when we have linked data, it's gonna be broken down in, do I have a nice, yeah, something kind of like this, where we have some object that's just this very simple little object that's gonna hold two pieces of information. It's gonna hold some data, or a reference to some data, and it's also gonna have a reference to next, which is gonna be another node. So if we go back here, these little blue arrows here are references to the next nodes. And each of these boxes here will have some container or some reference to some data, but that's not shown. So a couple of things of terminology is we'll refer to these things as nodes. These are references to nodes, the little arrows. And usually we'll have some reference variable to the head of this link structure, like the one at the very beginning, and that's called like a head. So these are some general terminology. Nodes, references to next nodes, and head. There's really not much there. Okay, so with links idea, like these link structures are, here, paint. Of course, this is not plugged in, never is plugged in. Where the heck? Where the heck? I've got too many USB cables. Honestly, there we go. So with an array, the idea is we have some like block of contiguous data, right? You know, this is all right. So this is like the idea of our array. But with nodes, it's a little different. With nodes, we have like just the node, which has some data in it, but it's a reference. It also has a reference to another node, which might be somewhere entirely different in RAM, which has a reference to some other node, which has a reference to some node that's over here, which has a reference to a node that's right next to it. But that also has a reference to a node over here in RAM, and then this has a reference to a node over here in RAM, and so on. The nodes are just, like, it doesn't matter where the nodes are. All that matters is that I know how to get to some subsequent, some successor node. I hear a boop. Get a USB splitter. I already have one, it's just not big enough. This is different from nesting. Yes, but I'm not sure what you mean in the like when you say nesting here in this context, but it's, with what I think it is that you mean, it is different from nesting. Okay, come on, where's my mouse? Okay, so with linking idea, we don't need to store data in consecutive memory locations. Successors can be anywhere, like I was drawing. And we can insert and delete things without having to shift data. So, for example, if I wanted to add a node between, like, green, if I wanted to put a node in between this thing and this thing, like let's say these were numbers, like 1, 2, 3, 4, 5, and so on. But I wanted to add like a 3.5. Well, I can make a new node, put a 3.5 in it, and then say, no, you don't point there anymore. We'll just have it go like this. We just plop it in the middle. Nothing needs to shift around. Where if I had 1, 2, 3, 4, 5, and this goes on forever, if I wanted to add a 3.5, I got to move everything down 1, right? Where with this node, I just make a new node, plop the 3.5 in it, and just kind of like update the references, which is pretty cool as well. Is there something like the alias? Is this something like the aliases? No. How much faster is this? A lot. Are the references like pointers? The references are... When you say references like pointers, can you be more specific as to what you mean? Because that could be a complicated question depending on where you're coming from. In terms of n. Okay, I think... So, in terms of the sad face... yeah, references are effectively automatically dereferenced pointers. Yeah, they're basically like a pointer to the memory address. Doesn't work well? What doesn't work well? Are there situations like this? Are there situations this method doesn't work well? Well, right now, I'm just describing an idea. There's no, like, method here. But in terms of the sad, I don't know, is that like a Kirby's Epic Yarn or sad face or something? Well, whatever. In terms of that question, this is going to be a lot faster. Where with the other one, I got to shift everything around. That's going to be n. It's linear time. I got to move everything. With this node, it's constant time. Just make a new node, update those two references. You guys, it sounds like you're all asking the right questions. Your head's in the right spot, but just stick with me and maybe we'll fill in some of the gaps as we go. Yeah, we can insert and delete things without having to shift data around, and link structures do not have a fixed size. I can arbitrarily keep adding to this, right? I can come along and go, okay, here's another node, and here's another node, and here's another node. The array, I'm going to have a fixed size. There's an end. I can keep appending to the end of these link structures forever. I mean, theoretically, there's this, like, limitation of RAM I have, right? But I could just keep going on and on and on and on and on and just keep appending to the end. I don't need to expand capacity ever. If I ever wanted to add more information, I want to add another number. All right, 17, new node, and then have the, it's referencing that. Yay. Can one node reference two nodes, or is there only one path? You could have as many, any node can have as many references as you'd like, but for now we're going to talk about these nodes with like singly linked nodes. They all have one single reference, but you could have as many as you want. But for now, we're keeping it simple with one. Okay, nodes. A node is a basic unit in our linked structure. So a node is one part. The whole thing together is the linked structure. We're focusing on singly linked structures, so there's the answer to your question, where each node has only one link. The series of nodes linked together is what makes up this singly linked structure. They link to their successors, like the next thing. Now you'll notice though, like if I'm here and I say, oh, what's my next? Well, you go like, well, it's this blue one. And how do you get there? Well, just ask for this node's next. But if I'm here and say, well, where's its predecessor? You're going to go, well, I don't know. Like, I mean, I know where it is. Like, I can see where it is. But from here, how do I get there? Because this node only has a reference to the next one. It doesn't have a reference to, like, the predecessor. Only the successor, which is interesting. So, yeah, the node is a simple data structure. Very simple. It's just this thing that's going to hold on to some reference to some data and a reference to some successor node. A node for a singly linked structure typically has two fields. Data, the stuff that we want to hold, to compare to the array. This is the stuff we're putting in the cell of an array. And then next is a reference to the successor next node. And arrays don't really have this because you get it by like default, right? Because the successor is just the next index in the array. So you don't need a next. You just go, okay, well, which index am I at? Well, the next one's at that index plus 1. So this next idea isn't really there with an array because we get it for free just by how arrays are built. How doesn't it doesn't know its predecessor? Not with the way we're describing it. Is a node an instance of an object? Yes, exactly is. So you can't pop if you know what I mean. No. Can one node reference? Okay, so Is a node an instance of an object? Yeah, a node, well, I mean, we'll define a node class, and then we can make instances of nodes. So we'll have a lot of node objects that are referencing each other. All right, inserting into a linked structure. So here's the idea here. Now I'm just going to pose a couple of thought questions for you. I'll start by saying, okay, given this link structure, you have something in your code called head. That's a reference to the head of your linked structure. And you know that your linked structure references a node, and that node has the data and the next. Presumably you have like a get data, get next, right? So with this information, how would I access the first item's data? Well, I would say, okay, head, which is a reference to this node. So now I have that node, and I can say, okay, well, head dot get data, right? Because the head references this node, and then this node has some field data. But how would I access the second item's data? Well, head is a reference to this node. But I can ask this node for its next. So I can say, head, give me your next. Well, that gives me this greenish node. And then I can say, get data. So head.getNext.getData. Third ones, well, similar idea. Head, get next, get data. But the trouble is, how do you access the predecessor? Well, we're in trouble because every node only knows where its next thing is. It doesn't know where it came from. So if I'm at this green node here, how on earth do I get to my predecessor? We're in trouble, right? Okay, so let's move on a second to, I'll zoom out just a titch. Can it go backwards? No, not with our design. Would the n item be at index I? Nope. Yeah, there's no such thing as an index. So, how would we add something to the front of the link structure? Look at this for a second, and I'll give you a moment to think about it. How would I add a node that goes in the beginning of this structure? Take a second and think about this. And then, I mean, we have other problems. How do you add to the middle or end? How do you remove something from the front, middle, or end? Well, we'll talk about this. So, adding to the front. Here's my situation. I have a new node with some data. Okay? And I want this to be the thing that's added to the front. But here is my linked structure. This thing right here. Head references the beginning of it. I want to add this blue one to the front, so it'll go blue, yellow, gray, black. Well, I have a reference to the new node. I have a reference to the head of my link structure. Here's what I do. As I say, okay, my new node, your next, set it to what head references. So now we've got an alias. So the new node's next is the head of the original link structure. Then all we have to do is say, okay, now head is pointing to the yellow thing, is the yellow box, but that's not the head anymore, right? So now we can say, well, head, you're equal to node. You reference what node references. So boom, head equals node, there we go. Now, the blue one is at the beginning. All we had to do was these 3 steps. New node, set the new nodes next to the head, and then update head to be the new node, which is the one we just added to the front. So what's the difference between the head and node? At this point, they're nothing. It's 2 references to the same thing. We have an alias. But the point is, head is a special value that, like, it's a special variable that's always a reference to the beginning of it, where node is just some arbitrary thing. Now we can make node go do something else. But head must always be pointing to the beginning unless we're in that transitional period of like updating what the head is. What is the new node's next? Well, is that What is the new node's next? Well, the new node's next is yellow. So here, I've got the new node, the blue one. Head is the yellow one. Set the new node, say, hey, okay, you're next. Set it to be what head references. So the yellow box. So the new node's next will be what head was. So you can change the reference in blue to be yellow. Well, we can change the reference next in blue to point to whatever we want, to reference whatever we want, really. So I'm just saying, yeah, set it to yellow. In fact, I'm wondering, maybe it'll be easier if we go and talk about the node class. How about this? First, I'm going to write the node class. Then maybe once we get a sense of what the node class looks like and what we can do with it, talking about the inserting at the beginning and end and whatnot will make a little bit more sense. So the head has multiple nodes, but isn't a node. The head is a reference variable to a single node. But the head isn't a node. You're right, it's not a node. It's a reference to a node. It's a reference to a single node, though. Can you change the color? Well, assuming the color is data, you could if you wanted. But let's write a node class. So here, source, new, Java class, node. Perfect. I'm going to want it to be generic. Okay. Okay. Our class is going to have two private fields. Private, something of type T, data, and then private node. Do I need it to be of type T? I can never remember. Yeah. Okay, node of type T. Next. So, we're saying that this node class has two fields. Data of whatever type T is. Remember, it's generic. But it's next, which is actually a reference to something of the same type, which feels a little weird the first time you see it, but it's totally fine. There's nothing stopping me from doing this. Next is a reference variable to a node, which is kind of what I was trying to draw here, right? So this red, which is coming from inside this node object, references a whole new node. This one right here. I hear a boop. Okay, so you're implementing the node just like you did the stack. It's not an interface. Yeah, I'm implementing a node right now. No need for an interface or anything. Okay, I'll write a default constructor, just a public node. And this constructor is not going to take anything, whatever. And it's going to set data to null and next to null. Okay, I'll just leave the default constructor for now. We could add more if we wanted later, but for simplicity, I'll leave them there. So we've got our node class. I wrote the constructor, which just assigns the values of the fields to null, a reasonable default value. Then I just want getters and setters. Get data, get next. Okay, here's my get next. Get data, set data, set next. And I was lazy and basically let my IDE, IntelliJ, write those for me. Right? So that's it though. That's all this class is. Two fields, the constructor sets some default values. I can get the data, I can set the data, I can get the next, I can set the next. That's all. I'm gonna go to lecture 1, make a new node. Node of type integer, because integers are easy. Equals a new node. Great. So now if I say sout, my node get data, what would we expect this to be? Well, we should expect it to be null because it's null because by default, all we did was run the constructor, look at the constructor. All that did was set data to null. So then when we get data, it returns whatever data is, which is just null. Similarly, let's close that. Similarly with get next. Nothing there. But I can now come along and say, okay, my node dot set data to 11. And now I'll ask the data. Maybe I should call this head. I'm going to call that head because it's like the head of my linked structure. So run. So I made the node, set its data to 11, and then I say, okay, head, give me your data. All right, it's 11. So now let's set a next. Well, if I want to say head dot set next, well, look, I need to give it a node of type integer. That'll be the new next, right? So here's what I'll do. A node integer new node. I'll call it a node equals a new node. Okay, there we go. So I created a new node. A node dot set data to 22. And then I'm going to say, okay, head, your next is a node now. Okay, now think about what the result of this should be. I want to be very clear. Nothing about what I just did is a trick. There is no trick. If you want to find out what this means, I recommend, 1, look at the code. Don't make any assumptions. And 2, draw out what's happening. If you haven't gotten yourself a whiteboard or something for easy scratching ideas down yet, now's the time. One of the best investments I made when in undergrad computer science was buying a little whiteboard for myself so I could scratch all these ideas down. Because when you, like, you know, a sheet of paper and pencil is great and all, but when you're like changing what things references all the time, you're going to want to be able to erase real quickly. So look at this and think, what does that mean? I'll give you a second and see if you can visualize what's happened here. Raise your hand if you have, you don't necessarily need to be that confident in your answer, but raise your hand if you think like, yeah, okay, I think I know what's going on. Just want to see the hands go up. And leave the hand up for a second. I just want to get a sense. If you don't, could you explain node constructor? I will in 1 second. I have a feeling you're overthinking the node constructor because it really is fairly, it's a rather silly, like dumb constructor. Okay, I see a bunch of hands up. It looks like about, what do we got? 16, 17 people of the 34. Oh, almost exactly half. Okay, cool. Okay, you can put your hands down. Now, to answer your question first about the node constructor, all it is I just set the 2 fields to null. That's it. There's nothing else happening there. In fact, I technically don't even need to put these there. Because by default, these are set to null. But just to be a little more explicit there, okay, take data, make it null. Take next, make it null. So with this constructor, let me, I have some node with a reference data that's null, and then a reference next is then set to null as well. That's what the constructor does. But back to what this code here is doing. So let's start one line at a time. Okay. So we have, okay, I have head, which is a reference to this node. And then by default, the 2 references in here point to nothing. So I'm going to leave them blank because there's nothing really going on there. I just have this new node and it's basically it just exists now. There's nothing fancy, it just exists. Then I say, hey, head, set your data to 11. Oh, okay, all right. So I'm going to draw this with like a green arrow. Set data to the number 11. Whoop, that doesn't look very good. There. So data now references 11. D for data. Great. That's the 2 lines of code right there. Create the node, nothing there, then immediately set its data to 11. Then what am I doing? All right, make a new node. Okay. Let's make this blue now. I called it like, a node is a reference to this node right here. Okay. But again, with the constructor, just after this line of code, the new node, a node, doesn't have the data and next set to anything. It's just there. It just exists and it's waiting to do something. But then immediately I say, okay, a node, set your data to 22. Oh, okay, all right. So let's do that purple this time. So I have data, and you now reference the number 22. Great. But that's it. An A node and head, at this point, their data references the integer 11 and integer 22, but neither has a next referencing anything. This is our current situation. In my main method, I have a reference to a node called head and a reference to a node called a node. And those nodes both contain some data now, but that's it. The magic happens on the next line. Head, set your next to a node. Okay, so what does that mean? Well, first, if we click this, what we see is, well, all set next does in the node is change what the field next is. So if I have, I'll just go black now. So next, Alt N, set your next to what a node is. So a node is a reference to this node, so just set next to be a reference to this node. So now we have an alias. Heads next and a node are references to the exact same single one node that contains the data 22. The literal single one there, they're equal because they're the same. It's not that we have a copy of that node. No. There's one node, but we have aliases. We have 2 references to the same thing. One is heads next, the other one is a node. A bunch of questions here. When you first create a node, does it very temporarily become the head of its own before? I mean, technically, yeah. So nodes hold data and a reference pointer. That's it. That's all it is. That's all. And if you're trying to do anything more, you're working way too hard and you're doing something wrong. All it is a stupid little object that holds some data and a next node, a successor. So does the successor to 11 have to be a higher? No. You're looking to make things more complicated. Stop making things more complicated. All it needs to be is a reference to a node of an integer. That's all that matters. A reference to a node of type t, where in our case the t was integer because, well, I said it was an integer. It doesn't need to be a bigger number. In fact, let's negative 22. So now I'll go back to my drawing and add a little negative there. Stop working so hard. You guys are looking to make things way more complicated. Can a node hold a string or Boolean? A node can hold, it's generic. It can hold whatever you want. All I have to do is go here and say string. I mean, this is going to be angry because 11 is not a string, but I can turn it into the string 11 and then this into the string negative 22. And now it's fine. String. There, now it's happy. But it can hold a reference to whatever type we want. We just specify it because it's generic here. But once we set them, we're going to want them to be consistent. Like they're all strings, right? I'm going to go back to integer though, just to keep things simple. Can I hold more than one data type at once? You could do it that way, but now you guys are trying to work way too hard here. Keep things simple. How do I go to the predecessor if I accidentally next to a successor? You're screwed. You can't. That's it. I like the questions you're asking, but you're getting too far ahead of yourselves. You're looking to make things more complicated. This is all we have here. I have head. That is a node. It's a reference to a node that has a reference to some data, 11, and a reference to a next, which is this blue one here that has a reference to some data, which is 22, negative 22, and a reference to next, which is technically at this point, nope, I'll draw it here, and which references null. That's what we have. So, if I am saying head, get next, get data, what am I expecting? Well, head is a reference to this. Then I say, here. Head is a reference to this node right here. And then when I say, hey, give me your next, well, it gives me a reference to this whole node here. And then I say, okay, now that node, give me your data. So that data, which is a reference to negative 22. So if I hit run, I should see negative 22. Negative 22. What would you expect now? I'm not saying give me the data. I'm saying give me next. What's next? What is the head's next? What is it? Null. Exactly. Why? Well, head, well, that's this. Its next is this. And its next is this, which is it's null. So there's nothing there. Okay, why is head next the first instance in the collection? Well, there's no collection here. This is just a stupid little node. And not the second one. 11 and not 22. Well, I mean, I could make it, but I mean, why is it? Well, because I wrote the code to say, okay, head references 11, and then head's next is this new node that has negative 22. I could do it the other way, but it looks like, I think you're trying to connect some dots that aren't there. This seems easier than stacks. Does that make sense? Yeah, sure. Like, the first code printed 11. Well, when I say head, get data, we should see 11. Because head's data is 11. Okay. Look, it looks like you're good though. So you think this is easier than a stack? Well, okay, that's great. It should be. So head is the default value. No, there's no default value here. What are you looking default value? All I have is a node. All we're doing right now is playing with a node, and a node can have two fields. That's it. There's no default value here. Head in our case here is a reference to the thing at the head of this linked structure at the beginning. But that's it. This is not a data structure. This is not anything fancy. It's just I'm playing with node objects. That's it. So you just set it to 11 just because. Exactly. It's arbitrary as hell. I just said, you're 11. Why? Because I could make it 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to hit run. And now it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Why? Because all I did is I created it and gave it some arbitrary value. And then I created it and gave it a reference to a node that also had some arbitrary value. Head could have been null, and then next has 22. You mean head's data could be null? Because head can't be null. Because you can't ask null what its next is. But if I want, I could have left this blank. Now hit run, and then its data will be null. But the node itself has to exist. Head's data I meant. Okay, good. Yes, exactly. Head can't be null because null is null, not head. Yeah. And you can't ask null what its next is because null's going to go, what the hell? I'm null. I'm not a node. I'm null. I can't. That means that's not a thing. Okay. Other questions about what we just looked at? I want to be very clear that all the questions you're asking are really good questions, but you're working too hard. You're trying to connect dots that aren't there. All we're doing right now is this stupid little class called node that has two fields that we can get and set. That's it. well, it depends on what you mean, Kai. If you're saying like, I can make these characters, I can make these friend objects if I want, right? I can, but I'm not gonna wanna mix them. You could write this in a way such that you are mixing them, but we're not gonna. You're making things too difficult for yourself. Just leave them alone. What is T? Well, that's the generic. T is a stand-in for what the type is. So when I say integer, you go look at node. T is now integer, so this means like integer. T is like a variable for a type. So the data, well, what's its type? Well, it's T. And then at creation, oh, it's an integer. If I make this a string, okay, well then, okay, the data is going to be a string. It's just the way we get to specify a type. Because otherwise, I'm gonna need to write a node for ints, and then a node for strings, and then a node for characters, and then a node. No, I want to write node once and then have some arbitrary type in it. That's the generic stuff that we talked about a little while ago. Can you put stacks in a node? Sure. Why not? Look. A stack of type node of type integer. Yep. With generics, you can do whatever the hell you want. Doesn't mean you should, but you could. So this is a node where the data is a stack, where the data on the stack is nodes of integers. Why? Because. Don't work too hard, but there we go. Can you have node with two different types? You can, we're not gonna. We're not gonna work that hard. If we want our nodes and our link structures, okay. I think what you mean when you ask sad crying face, I think what you're asking is, can I have a linked structure with nodes in it that have references to different types? If that's what you're asking, you can do that, but we're not gonna. That's working way too hard. So T means no specific type, can be any type. Yes, but once you put in T, like once I say here, integer, it's integers, and they're all integers. I can have head of ints, and then I could have a different linked structure called head of strings if I want. Like, that's fine. But they would be like separate linked structures. Okay, I think I hit all the questions. Although I think I see a hand up. Dippy McSkippy, you got a question, or is your hand just still up from before? Okie dokie. Okay, now with all this, let's go back to thinking about these things. So let's go back to adding to the front. I've got a node. I've got a head that's a reference to the beginning of some link structure that I think is really important. Maybe this says the number like 1, 2, 3, and then someone's like, you forgot 0. Okay, so you want to put a node with the data 0 in it. That is the new head. So I've got this. I say, hey, the new node, your next is what head references. So you have aliases here. They're both referencing this yellow block that was head, but that's what we're kind of changing. And then we say head, you reference the same thing the new node references, which is this blue box, which is the node containing the data 0 in that example. So this is a way to insert something to the front. If I had an array, I would have to do something like this, right? If I had an array, and I've got all this data here, and you wanted to put something in here, and I have the number 1, 2, 3, 4, 5, and so on. If I wanted to insert something in the front, I'm gonna have to go, okay, move that down, move that down, move that down, move that down, move this down, and then, okay, now I can put the 0 in there, right? Where with the link structure, it's entirely different. I just create a new node, and then just kind of like say, okay, well, the beginning, well, now this is the beginning. Update what the beginning is. Is there a way to return all things in a link structure, like a toString? Well, at this point, it's just a link structure. There's not, like, you're talking about a link structure. I mean, of course you could do something like that, but you're getting far too ahead of yourself here. We're just talking about nodes. So is the first node you write in source code the first node in the link? Well, both of these, at this point, after writing these 2 lines of code, I have 2 references to node objects. Every single time you make a node object, and if it has no successor, it's like the beginning of its own linked structure where it's the only thing in there. But if I start stringing them together, like you're looking to connect dots, I think. Stop trying to connect dots here. So is the first node you write the head of the... I'm not sure what you mean, but I have a feeling that what you're trying to do is not something we need to be worrying about right now. Can you loop because no index? What do you mean? Can you make like the black one reference blue after this? Totally could. Hell, I can do that right now. I can say head events dot set data to 11. Here, let's do this below. Head of strings, which is still ints, set data to 22. Head events dot set next to head of strings, and then why is this mad? And then this is head of strings dot set next to head events. I don't know why this is angry. Shouldn't be. Let's see what happens if I run it. Maybe it's just, what am I missing here? Cannot convert Java lang type. Java lang integer, Java lang integer. Node. What? Oh, set data. Set next. Does someone call me out? Yeah. Good catch. So run. Okay, so it's not angry. So now I can say s out. Okay. Head events. Get data. What should that be? Get an answer in your head. What should that be? 11, because head events data is 11. So now I'm going to say head events get next dot get data. What should that be? I'll give you a second to think about it. And I'll hit run. We see 22. Why? Well, because head events is next is head of strings, which has the data 22 in there. But now what if I do this? So what is head events next data? Take a second, look at the code. What does it say? There's no trick here. If you're thinking, whoa, he's doing something weird. No, I'm not. I'm like, what does the code say? The code is doing exactly what I tell it to do. So I'll give you a moment. And I want you to raise your hand in the chat if you have an answer in your head. You don't even need to be that confident, but if you're like, no, I've got what I'm committed to. Not a lot of hands up, so if you're really stuck, draw it. In fact, let's draw this. I'll actually draw it with a circle now. I've got green, and then blue. Okay, and this is let's do HOI, HOS, because it's head of strings, which doesn't make any sense. And for ease, even though they're references to integers, for ease, I'm just going to write them as 11 and 22 inside the nodes because it's just a little easier this way. And then I say HOI, head of ints, your next is head of strings. So your next is now a reference to this node. And then I also say head of strings, your next is head of ints. Okay, so you know your next is a reference to this node. So with this drawn, put your hand up and keep your hand up if when I ask the question, head of ints, get next, get data. Head of ints, well, that's this one here. And leave your hand up. Leave your hand up. That's this one here. Get your next. Well, that'll take me over to here. And then I say get your next. Well, that's this, which then takes me all the way back over here. Get your data. Well, that's the 11. Let's verify I'm right. 11. So now, what happens if I do this? Head of ints, get next, get data. Well, head of ints, well, that's this. Get your next, 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 that's this. Get data, that's that. Let's make sure I'm not crazy. It's 11. Now, this is rather silly. I want to be clear. What I'm doing here is fairly silly, but the point is I can. All head of ints is a node that has a field data, has a field get next. And get next just needs to reference some node. Hell, I can do something like this. Head of ints, your next is yourself. So what that would mean is this. I shouldn't have done that. Where now my next is this. Oh. So now head of ints, its next is a reference to itself. So I can add a bajillion get nexts. Okay? Look at this. I have 1,528 characters in this list. So I don't know how many. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's, I don't know, there's on the order of, there's over 100 get nexts. But all that means is, okay, HOI, get your next. Okay, well, my next is HOI. Next is HOI. Next is HOI. Next is HOI. I'm just asking, like, I'm getting a reference to myself like 100 times. Let me scroll all the way back. So it should still just give me 11. Let's make it 111 just to make sure it's not doing anything else from before. 111. This is silly, though. What I'm doing is silly, but I can do it. Okay, I see a bunch of questions. Okay. Okay, you have set data instead of set next. Yeah, that was a problem. It loops. Is there a way to use a variable amount of get next? Yeah, you can use a loop. This is going to be on YouTube. Yeah. Answer is 11. 22. Okay, bet shill. Okay. So what? It's always 11. When I did it the second time, yeah. Okay, yeah. I'm going to upload this to YouTube right now. But we'll pick up here on Friday, I guess. Cool? Cool. All right. I'll see you all later.